Thank you, Kev. Thank you. Hi, everyone, and welcome to Data Weekender from my side. And yeah, I hope you're enjoying the conference so far. Personally, this is one of my favorite conferences. I remember watching the first edition during it was somewhere beginning of pandemic, and then I was lucky enough to be a speaker in all subsequent events on Data Weekender. So I'm always happy to be here either as a presenter or to support with moderating sessions and so on. And yeah, from my side, good morning, good afternoon, good evening with these virtual conferences. You never know from which parts of the planet people are joining. And welcome to my brand new session, which is called Fabric Bread and Butter, a Whirlwind tour on OneLake and Data Engineering. So yeah, before we start, you will see, and I will set some expectations before we proceed. This is like a high-level overview of OneLake and data engineering workload in Microsoft Fabric. So it's more beginner-friendly, and also for people who are transitioning from other platforms or considering transition from other platforms to Fabric, I think they will find some useful information in this one. But this is definitely not a deep dive on any specific feature or any specific concept in Microsoft Fabric. So it's more of a high level overview and introduction to these two, in my opinion, core components of Microsoft Fabric. And you will see why I consider those two as core components. Few words about myself. Kevin already mentioned a few important things. The most important thing, I'm a huge football or soccer fan if you're based in USA, and huge Barca fan. So as you may conclude looking at the photo on the screen, which was taken last year, no, 2 years ago, sorry, before Camp Nou, the stadium of Barcelona was destroyed. So this was one of the last games in the old one. Other than that, I'm based in Salzburg in Austria, where I work as an independent data platform consultant and trainer, mostly focusing on Microsoft technologies, Power BI, namely Power BI and Microsoft Fabric. You can find me on the web. I'm blogging at data-mozart.com. I'm also active on social media. So yeah, if you feel free, if you feel like you want to chat about data and everything related to data, yeah, then feel free to get in touch. I'm also currently finishing the book called Fundamentals of Microsoft Fabric together with Ben Weissman, and we hope to have this book published in the second quarter of this year. Now, let's kick it off. Let's kick off our session, and the first thing I want to discuss is the concept of OneLake. But before we come to this, I would like to take one step back in order to put our discussion in the proper context. So, like the majority of modern data platform solutions, Microsoft Fabric is also based on the architectural principle of clear separation between the storage and compute layers. In a nutshell, this principle enables computing and storage resources to be managed, to be scaled, and to be priced independently. From a Fabric point of view, this means that various workloads that are displayed in the top part of this illustration, such as Data Factory, real-time intelligence, databases, analytics, and Power BI, they represent a compute layer. On the other hand, OneLake represents a storage layer of Microsoft Fabric. Before we dig deeper to examine various OneLake concepts and features, at this point, I would like you to keep in mind that OneLake is built on the principle of one copy. As you will learn during the session, this principle ensures that one same copy of the data can be processed and can be consumed by multiple different compute workloads. Let's now try to define what OneLake in Microsoft Fabric is. In plain English, OneLake represents a central storage repository for the entire organization. When I say the entire organization, I really mean it. Hence, there can be no multiple OneLakes in a single Fabric tenant. So one Fabric tenant consists of one and only one OneLake. And all the organizational data should be stored there. If we take a look under the hood of OneLake, this is exactly what you are going to see. I'm using here OneLake Explorer, which is a very handy application that automatically synchronizes OneLake items in Windows File Explorer. And as you can see at the top level here of this hierarchy, I have OneLake itself. Within OneLake, there are one or more Fabric workspaces. If you open a particular workspace folder, there is a new level of folders. These are Fabric items, and there are different Fabric items available. In this example, I have a Lakehouse, I have a Warehouse, I have a Custo database, and GraphQL items in this workspace. And if I move one step further and open a specific Lakehouse folder, there is a new set of folders inside. These are individual tables which are represented as a set of files within each of the folders. So let me quickly show you how this looks like in this OneLake Explorer. So I downloaded this application and I'm synchronizing OneLake content with my Windows File Explorer. I'm now at the root level of OneLake. So those are different workspaces that currently exist in my OneLake, my Fabric tenant. So if I open, for example, this one, DP600 Bootcamp workspace, you see that I have multiple folders. Each folder represents a different Fabric item. I have Lakehouse, I have Warehouse, GraphQL, Custo database. And now if I open my Lakehouse, you see there are different folders again, files, table maintenance, and tables. And then if I open tables, again, new set of folders. For each individual table, I have a separate folder. And then, for example, if I open, let's say, DIM customer table, you can see that I have, in this case, I have two Parquet files. We will talk about Parquet files in a few moments. So I have two Parquet files and I have a Delta log folder. Don't worry if you are not sure what does this represent. I will explain in a few minutes. But essentially what I wanted to showcase in this example that OneLake is nothing else but a logical structure of files and folders. So that's how OneLake looks under the hood. It's probably easier to understand what OneLake is if I use this analogy with OneDrive, because I guess you all know what OneDrive is. And you can think of OneLake as OneDrive for all the organizational data. Now, let's wrap up this intro about OneLake by using the old saying, all roads lead to Rome, right? Well, not in this case. In case of Fabric, if you talk about Fabric, all roads lead to OneLake. So let's briefly examine why this is so true in Fabric terms. First, we have the data that is created by various Fabric compute workloads and is physically stored in OneLake. However, many organizations already store their data outside of Microsoft Fabric in multiple disparate locations. It can be a different Microsoft data storage solutions, such as Azure Data Lake Storage Gen 2 or Azure SQL DB or Azure SQL Managed Instance, but also a solution provided by a different vendor like Amazon, like Google, Databricks, Snowflake, and just to name a few. So if you recall the principle of one copy that we already mentioned, how would this principle be possible if we needed to move the data from its original location to and create another copy in Microsoft Fabric? So let me briefly introduce two innovative concepts in Microsoft Fabric, and we will examine more about this in later part of this session. The first is shortcuts. As I said, we're going to talk and examine shortcuts in more depth in the second part of the session. I'll just here say that shortcuts are one of the most remarkable Fabric features. In a nutshell, shortcuts serve as pointers to the data that is stored in a different location, which can be both internal and external to OneLake. In this illustration, you will notice that shortcuts can be created to external storage systems such as Google Cloud Platform, Amazon S3, Dataverse, or Azure Data Lake Storage Gen 2. The second concept is called mirroring. Simply put, mirroring enables the creation of real-time Fabric replica of the data which is stored outside Fabric in data sources like Snowflake, Cosmos DB, Azure SQL DB, or Azure Databricks without the necessity to set complex ETL processes inside to bring this data inside Fabric. Now, if you watch recording of this session in a few months, maybe there will be some additional data sources supported for both shortcuts and mirroring. But as of today, so speaking about March 2025, those are the data sources that are currently supported for both shortcuts and mirroring features. Okay, I promised I will talk about how the data is stored within OneLake. So if you remember this folder and file structure that I've shown you in OneLake Explorer, if you go to the lowest level of this hierarchy, so to the particular file, that's the way data is physically stored in OneLake. The format of choice in OneLake is Delta Parquet, as Microsoft likes to call it. I don't like this name, but that's another story. Although there is no such thing as Delta Parquet officially, only Parquet as a format for physically storing the data, which was introduced by Apache, I think back then in 2013 or 2014, something like that. So why Parquet is a big deal and why Parquet was the default choice when storing the data in OneLake? There are at least 5 main reasons, I would say, why Parquet is considered today, still considered a de facto standard for storing data in analytical systems, of course. First one is data compression. The idea is that when you apply various encoding and compression algorithms, Parquet file provides reduced memory consumption. Then columnar storage. This is of paramount importance when we are talking about analytical workloads, because fast data read operations, this is the key requirement in analytical scenarios. It's also language agnostic. That means developers may use different programming languages to manipulate the data in Parquet file. I'll name just a few: PySpark, SQL, Scala, R, and yeah, there are more, of course, but it's language agnostic, so you can manipulate the data from Parquet file using any of these languages. It's open source format, meaning you are not locked with a specific vendor. Meaning if you are not happy with Fabric after some time, you can simply pull out these Parquet files and move them to another vendor that supports reading data from Parquet files, and you can continue using them and using data stored in those Parquet files. And they also support complex data types. Now, we've already mentioned that Parquet is a column-based storage format. However, to understand the benefits of using Parquet file format, we first need to draw the line between the row-based and column-based ways of storing the data. So when we talk about traditional row-based storage, the data is stored as a sequence of rows, something like this you can see on your screen. Now, when we talk about analytical scenarios, some of the common questions that your business users may ask are, how many balls did we sell? Or how many users from the USA bought t-shirt? Or what is the total sales amount spent by customer Maria Adams? And so on and so on. To be able to answer any of these questions, the engine must scan each and every row from the beginning to the very end, because data is stored as a sequence of rows. Don't forget that. So to answer the question, how many users from the USA bought t-shirt, for example, the engine has to do something like this. Essentially, we need information from 2 columns: product, we are interested in t-shirts, and country, we are interested in USA. But the engine will scan all 5 columns. This is not the most efficient solution. I think we can agree on that. So now let's examine how the column storage works. As you may assume, the approach is quite different. In this case, each column is a separate entity, meaning data in each column is physically separated from other columns. Going back to our previous business question, the engine can now scan only those columns that contain necessary data, product and country, while skipping scanning all the other columns. That's a huge improvement. In most cases, this improvement will bring significant performance boost for analytical queries. Okay, that's nice, but column store exists outside of Parquet, existed before Parquet. So what is so special about Parquet format? Parquet is a columnar format that stores the data in row groups. So there is additional structure within Parquet format that was introduced that basically also does a horizontal separation of the data. Let's stop here for a moment and try to explain the illustration you see, because this is exactly the structure of Parquet file. I've intentionally omitted few things, but from high-level perspective, this is how the data is stored in Parquet file. Why this additional structure, this row group structure, is so important? You'll need to wait for a few seconds for a definitive answer, but because I want to introduce two most important concepts in analytical processing scenarios. We are mainly concerned with two concepts when we are running analytical queries. First one is projection. This one refers to select a statement in SQL language. So which columns are needed by the query? Back to our previous example, we need only the product and country columns, right? So the engine can skip scanning the remaining rows. This is regular columnar storage. Now, we have another concept which is called predicate or predicates, which refers to the where clause in SQL language. Which rows satisfy criteria that we define in the query? Remember, we are interested only in t-shirts. So the engine can, in this case, completely skip scanning row group 2 because there are no values t-shirt in this row group. Okay? Now, let's take one step back, and I want you to realize the difference between various types of storage in terms of work that needs to be performed by the engine. In traditional row store scenario, the engine will scan all 5 columns and all 6 rows to retrieve the information about how many t-shirts did we sell in USA. With columnar storage, it's 2 columns and 6 rows. With columnar storage with row groups, which is Parquet, it's 2 columns and 4 rows. Obviously, this is an oversimplified example with just six rows and 5 columns, where you will definitely not see any difference in performance. But in real life, when you are running queries over millions or sometimes even billions of data, the difference can be really significant. And that's why Parquet is considered a standard, and that's why Microsoft also embraced Parquet as the default storage format in OneLake. Now, we were talking about Parquet, but I want to introduce another concept that really pushes Parquet as something that is special for storing data in OneLake, and this is the concept of delta format. Now, I like to think about delta format as Parquet format on steroids, and when I say steroids, what I mean is that basically the main one is versioning of Parquet files. It also stores transaction log to enable keeping track of all the changes that you apply to Parquet files. So this is, if you used to work with traditional relational databases, this is also known as ACID compliant transactions. So if I go back to my table, you can see here that I have 2 versions of Parquet file. And if I go, I have 2 Parquet files. And if I open my Delta log, these are nothing else but JSON files where I can see different versions of my Parquet files. And then I can go back and forth and do analysis at certain point in time. From a perspective of OneLake, once you open a table, this is how you will see a single table displayed or stored in OneLake. So it's a bunch of Parquet files. And if you open Delta log folder, you will see different versions of these files. Again, as I said, by running this command describe history, you will get the detailed overview of the changes that were made to a specific Parquet file. And from there, you can write a query that will retrieve the data from a specific version if necessary. I forgot to mention, but yeah, obviously, if you have any questions, just drop them in the chat. I'm trying to monitor while I'm talking if there are any questions. Okay, let's move on to explaining methods for data loading into OneLake. So now we learned what OneLake is, how the data is stored, but let's see how we can bring the data into OneLake. So we are slowly moving to this part of data engineering concepts and features in Power BI. First of all, Microsoft Fabric is all about the options, and one same task, as you will see once you start working with Fabric, or maybe you already realize that, one same task can be completed in numerous ways, using different tools, using different capabilities of the platform. And in this section, I'll try to examine various methods for loading data into OneLake. The key thing to keep in mind before we proceed is you first need to create some kind of compute workload in Microsoft Fabric before you can actually write the data into OneLake. When I say some kind of compute workload, this can be really whatever, Lakehouse, Warehouse, or KQL database, but whatever you choose, this workload must exist as a container, as a prerequisite to serve as a container for writing data into OneLake. Okay, now once we created this one of these containers, or maybe all of them, let's explore different data loading methods. And we'll start with the simplest one, which is file upload. File upload offers a drag and drop experience for quick manual upload of files that are stored on your local machine. Yeah, in real life, you probably won't use this so often, but keep in mind that this is the most simplest and most straightforward way to bring data into OneLake. The next one is copy activity in Fabric pipeline. We'll examine this in demo in a few minutes. This one enables efficient and reliable data transfer suitable for scenarios where you don't need to perform data transformation during the data ingestion process. Then we have Data Flows Gen 2, which provides feature-rich graphical user interface, which supports complex data transformation requirements. If you're coming from Power BI background to Microsoft Fabric and you're familiar with Power Query experience, Data Flows Gen 2 are nothing else but Power Query online for bringing data into OneLake. Notebooks. If you look for the code-first approach, notebooks are your best friend for sure. They allow for complex data transformations by leveraging a powerful distributed Spark engine architecture. Then we've already learned about mirroring. It creates a real-time replica of the data stored in supported external data sources. And last but not least, Event Stream, which is suitable for handling streaming data in those scenarios when you need to process the data as soon as it is created. Let's examine now a few of these methods in more depth. And I'll start with copy data activity in the Fabric pipeline. This is one of the most commonly used activities in pipelines. And by leveraging the built-in copy data tool, you can connect to various data sources. You see some of them listed on the in this screenshot on the screen. After you add copy data activity to a pipeline, you can go and configure its settings, and there is a panel underneath the activity where you can provide different configurations and other settings. Let's now explain Data Flows Gen 2. Data Flows Gen 2 enables you to leverage a low-code interface and more than 300 built-in data transformations, letting you transform data more easily and with more flexibility than any other tool that is currently provided in Fabric. So data flows are a type of low-code cloud-based ETL solution for building scalable and straightforward data transformation processes. They allow you to connect and extract data from multiple sources. No other method in Fabric supports so many data sources out of the box. So there are more than 150 built-in connectors that you can use to connect to a specific data source, and then using graphical user interface, transform this data and load it in Microsoft Fabric. Data flows can be run manually on a refresh schedule, or you can use them as a part of Fabric pipeline orchestration. We will examine this later in the session. So keep in mind that data flows can be both standalone item in Fabric that you can execute without any other dependencies, or you can use it as an activity within the Fabric pipeline while you are orchestrating the entire workflow of bringing data into OneLake. The key differences, because I think this is important, especially for people just transitioning to Fabric, the key differences between data flow Gen 2 and pipeline are you should use data flows to perform data transformation and data profiling operations. They offer a familiar Power Query experience, as I already mentioned, which removes a barrier for many existing Power BI professionals. Finally, again, as mentioned, data flows offer more than 150 connectors out of the box to seamlessly connect and work with the data stored in literally any available data source. On the other side, pipeline is mainly a data orchestration tool, meaning we use a pipeline to define the execution workflow of the data ingestion process. Copy data activity may be leveraged for some lightweight transformation, such as changing data types, for example, but this is not the main purpose of using a pipeline. So copy data is simply moving data from point A to point B without applying any transformations except changing the data type. And finally, keep in mind that pipeline can be a superset of data flow. If you use a data flow as an activity within the pipeline, then you can use this data flow as part of the orchestration process. Notebooks, if you ask me, notebooks are one of the coolest items in Microsoft Fabric. And I'm telling you that as someone who never worked with notebooks in past, but I love them more and more. So first, let's discuss what Fabric notebooks offer over the other data loading options. By default, Fabric notebooks will use PySpark language, which uses the Spark engine to allow a multi-threaded distributed transaction for speedy data processing. You can also use other languages. I think I mentioned some of them, such as Scala or Python, Spark SQL, R. You can also run T-SQL code inside the notebooks. Next, notebooks allow for writing comments using the Markdown feature, which significantly increases the value of the entire code writing process, especially when you write comments and you open this notebook after a few months. You will be grateful to your former self because of using this feature. You can run or freeze individual or multiple cells within the notebook, and they are really great tool for data ingestion and data transformation. Also can be automated. So unlike some manual uploads or some other methods that don't support automation, notebooks are great in that regard. Finally, event streams enable you to bring real-time events into OneLake, and optionally, if you want, you can also transform them during the process of loading the data into OneLake. They are also based on a low-code or no-code approach, so everything is done through the graphical user interface. Numerous sources are supported, as you can see on the screen. Many of them or most of them are related to events happening in real time, and you can store the output of this data ingestion process in different destinations within Microsoft Fabric. In most cases, you are going to use Event House because the main purpose of Event House item is to store streaming data, but you can also create a derived stream, for example, or you can store the data in a Lakehouse, or create a Fabric activator item to perform a specific action based on the data points you are ingesting. Here I've included a very simple table that essentially gives you a high-level overview of when to consider which approach. You will see that if you are searching for a specific connector, Data Flows Gen 2 is definitely the way to go. As I said, they support more than 150 connectors out of the box. If you have requirements to load large data without any complex transformations, if you are preferring a low code or no code approach, then use copy data activity. If you are a code first person, then notebooks definitely. If there are complex data transformation requirements, either data flow for low code approach or notebooks. For streaming data, as already mentioned, there are event streams. I would like to quickly show you how easy it is to create. Let me just find my Fabric workspace, a data flow Gen 2. So essentially, I'm now in my Fabric workspace, and I'll start here by clicking on New Item. Here, if you cannot find it, simply search for it. Data flows. There are two types of data flows. Don't be confused. Data flow Gen 1 is the old version that existed before Fabric and still exists, works only with Power BI. But in this case, I want data flow Gen 2. Let's give it a name, Data Weekender. And I'll click on create. Now, this is a very familiar user interface for everyone who ever worked with old data flows or with Power Query in Power BI desktop. So first step is obviously to connect to a data source. If you click on get data and then on more, this is basically all of different data sources that are supported. As I mentioned, really, you will hardly find any data source that is not supported out of the box with data flows. Now, in this case, let's connect to SQL Server database. And let's connect to my local instance of SQL Server. I'll connect to AdventureWorks database. And one important consideration is when you are connecting to on-premises data sources, you need to have on-premises data gateway installed, obviously. So nothing changed in that regard. I already installed my on-premises gateway. I updated this morning, so hopefully this is going to work. Let's see. And now I can pick tables that I want to load into Microsoft Fabric. So let's take dim currency and dim customer, something very simple. Now I can perform different transformations. So let's say here for dim customer, let's say I want to merge first name and last name. So I can click on these two columns, say merge columns. Separator will be space and new column name will be full name. I'll click OK. So I'm performing now transformation on this table. And the most important thing, you need to specify a data destination. So I'll click on plus sign here, and then those are the available destinations for writing data from a data flow Gen 2. In this case, let's choose a lakehouse in Microsoft Fabric. And then, for example, I go to my DP600 bootcamp workspace. I'll choose my DP600 bootcamp lakehouse. Okay, maybe I need to change the name of the table, but doesn't matter. And once I click Save Settings, so here I can change data types if necessary. Once I hit Publish button here, this data flow will be published to Fabric Workspace. Let's do that. And it will be automatically executed. So once the execution is completed, my tables will be part of OneLake. So they will be stored in the lakehouse, in the destination that I specified. This is how you can use a data flow. Again, as I mentioned, once it's done, you can open settings and set the schedule refresh, same as we did previously with regular old Power BI data flows. So data flow can be run on a specified schedule as a standalone item. But again, I will show you later how it can also be part of the wider data orchestration process. Going back to our presentation, talking about shortcuts. We've already scratched the surface of the shortcuts in one of the previous slides. Now we'll dive deeper to explain this concept in more detail. So shortcuts are OneLake objects or objects in OneLake that point to other storage location. Doesn't sound too exciting, I know, but I'm sure you will change your mind once you see shortcuts in action. First, let's draw the line between the internal and external shortcuts. Internal shortcuts, they point to other locations within OneLake. Think of a different lake house, for example. On the flip side, external shortcuts point to data sources that are not part of the Fabric ecosystem. Currently, the following external data sources are supported: ADLS Gen 2, Google Cloud Platform, Amazon S3, and Dataverse. Now, let me quickly break down the concept of shortcuts in OneLake. Here, I'm using the internal shortcut example. So let's imagine that we have a workspace A that contains two lake houses, Lakehouse 1 and Lakehouse 2. Lakehouse 1 contains few tables with data. Lakehouse 2 also contains a table which is named table 2. Now we need to ingest the data into Lakehouse 1. If you need data from table 2 in our Lakehouse 1, we need to ingest this data, right? Well, no. With shortcuts, essentially we can simply create a shortcut and we have this data available without physically moving it from Lakehouse 2. This is cool. But let's say that my lakehouse resides in a different workspace. In this case, I have workspace B, I have lakehouse 3, and have another table in this lakehouse. No problem at all. So you can still create shortcut pointing to delta tables stored in different lakehouses in different workspaces. Another thing to consider is the difference between the target path and the shortcut path. Especially if you go to Microsoft documentation, they will often refer to target path and shortcut path, so it's important to understand the difference. The target path represents the location that a shortcut points to, whereas the shortcut path is the location where the shortcut appears. In this case, you see the difference. How can you create a shortcut in Fabric Lakehouse? So I'll open my Lakehouse, this one DP600 Bootcamp. And here under tables, you can create shortcuts both in tables and files area. So I'll click here on 3 dots next to the tables. So here, I'll click on 3 dots and say new shortcut. Now this will launch a new dialog window. You see the difference between internal sources. Those are all the sources within OneLake, and external sources. In this case, I'm picking the internal one for the sake of simplicity. And for example, I will go to another location. So you see that, for example, this DP600 LH Lakehouse is stored in a different workspace. It's in DP600 Playground. So I'll click on that one, then choose next. And then I can pick tables and or files. In this case, I don't have files. Tables and or files that I want to include as a shortcut in my original Lakehouse, which is DP600 Bootcamp. So I'll choose this one. Let's say Contoso dim date. Let's say I don't want to recreate dim date table again. I want to simply reuse it from another Lakehouse. I'll click on next, click create. And after a few seconds, this table should pop up here. Let's refresh this. There you go. And you can recognize a table which is created as a shortcut by this small chain icon in the top left corner. This one here is also shortcut table. So this is how you create shortcut. And from this point, as you can see, this table can be queried, can be used as it was natively stored within this lakehouse. Even though the data is physically still in another lakehouse, I can now write a query. I can create a direct lake model in Microsoft Fabric and use this data as it was natively stored together in this DP600 Bootcamp Lakehouse. No questions as far as I see. Okay, then let's move on to explaining how to create various Lakehouse items. Once you create a Lakehouse in Microsoft Fabric, 2 additional Fabric items will be provisioned out of the box for you. Default Direct Lake Semantic Model for Power BI reports and SQL Analytics Endpoint. I will just briefly introduce Default Semantic Model later, but now I want to focus on understanding the role of the SQL Analytics Endpoint. Before that, you should be aware that the Lakehouse itself consists of 2 separate areas, files and tables. Files represent the unmanaged area of the Lakehouse. When I say unmanaged, I mean that it's not managed by the Spark engine. And here you can store the data in any format. CSV file, JSON, images, videos, whatever you want. On the other hand, tables represent the managed area of the Spark, which is managed by the Spark engine. And although you can technically store data in various formats, this one is more related to storing the data preferably in Delta format. I will explain why. The main reason is that once you store the data as delta format, it will be also automatically available through the SQL Analytics endpoint. SQL Analytics endpoint provides a SQL-based experience when working with the Lakehouse. The key thing to keep in mind is that the SQL Analytics endpoint is read-only option for the T-SQL engine, which implies that you can't insert, you can't update, you can't delete the data in the Lakehouse by using T-SQL language. So SQL Analytics endpoint exposes only tables stored in Delta Parquet or Delta format, and every Lakehouse comes with automatically generated SQL Analytics endpoint. You can't explicitly go and create a SQL Analytics endpoint item in the fabric. It's automatically provisioned once you create either a Lakehouse or a warehouse. Also keep in mind that SQL Analytics endpoint of the Lakehouse uses the same engine as Fabric Warehouse, which is a different engine compared to Spark. This is the engine that we know from Azure Synapse Analytics. As you already mentioned, SQL Analytics endpoint supports read-only operations over data stored in the Lakehouse. And this read-only concept doesn't mean that you can't create some of the familiar database objects, such as views, such as inline table value functions and store procedures, especially for store procedures. As long as your procedures are only reading the data from the Lakehouse, you are good to go. Also, you can leverage T-SQL language to manage object permissions, for example, with object level security feature. Okay, I see some questions. Let's take this one once we are done with the session. Okay, so this is how what happens when you create a Lakehouse, and what I wanted to show you quickly is those two areas of the Lakehouse. So we have two areas that we mentioned: files area. This one is not managed by Spark engine. I have some CSV files stored here, and I have tables area where everything is stored as a Delta format. Now, if I switch from Lakehouse view to the SQL Analytics endpoint view, you will see that only those tables that are stored in Delta format are exposed through the SQL Analytics endpoint. Here they are. As I mentioned, you can write views, you can create views, functions, store procedures, and so on. You can rely on schemas. Yeah, so basically this is more or less a warehouse-like experience that we know also outside of Fabric. So this one reminds of that. And from reporting tab, you can create semantic models for Power BI reports. Bear in mind that whenever you create a new semantic model based on the data stored in a Lakehouse from Web UI directly from SQL Analytics endpoint, by default, this semantic model will use Direct Lake storage mode. Now, Direct Lake is out of the scope of our session today, but this is again one brand new feature that Microsoft introduced with Fabric. Okay, going back to a presentation. So what can we do from the SQL Analytics endpoint? Query data from Delta tables, create views, inline table value functions, and store procedures for reading the data, that is important, and manage object permissions, as we already mentioned. Okay, so the next topic is data orchestration with Fabric pipelines. And in one of the previous slides, we scratched the surface of the Fabric pipelines topic when we introduced the copy data activity as one of the methods to load the data into a Lakehouse. So let's now take a broader view of pipelines and understand various components and features that are available to implement an efficient data orchestration process. The main building block of every pipeline is an activity, or which is more common in real life, a set of multiple activities. Besides copy activity that we already mentioned and represents a data movement activity, we can split pipeline activities into two major groups: data transformation activities, such as data flow gen 2, notebook, Spark job definition, SQL script, and so on, and control flow activities, which define the logical flow of the execution process. Some of the commonly used control flow activities are for each, if, set variable, lookup, invoke pipeline, and so on. All these activities together they perform a certain task. For example, I'll give you an example later. So they also support parameterization, and yeah, you can schedule the run of a pipeline based on your business requirements to run every X minutes or every Y hours, days, and so on. So usually, as I already mentioned, a pipeline common workflow is that you bring the data from outside, so you ingest it into Microsoft Fabric. Then you apply different transformations using notebooks, data flows according to your preferences. And finally, let's say that you are happy with these transformations. You store the data again in somewhere in OneLake, and then there is a semantic model that is built on top of this data in OneLake. You can also trigger the activity to refresh semantic model directly from a pipeline. How do you create a pipeline? Again, let's go back to our workspace, and I'll click new item. Here it is, data pipeline. So let's call this one data weekender pipeline. And once I click create, it will open, or it will create a new pipeline canvas. And here I can use copy data assistant. And for example, I can connect again to my SQL Server database, bring some data. That's okay, yes, cancel. Or I can directly here from activities, I can choose some of the most common activities from the top ribbon, like copy data. And then once I have this copy data, here I can configure it in the bottom part of the screen. In this panel, you configure the general settings, source. So here I'm defining the source, destination, and I can also provide some additional information for this copy data. Then after that, let's say that I want to use a data flow for data transformation. So I'll connect this and say whenever this copy data activity successfully completes, after that, I want to execute my data flow that I previously created. This is the one. And once I'm done with these transformations, I want to refresh my semantic model that is based on the data transformed within the data flow. So I will search here on 3 dots. Then you can see all the available activities. And let's find semantic model refresh. And once my data flow successfully completes, my semantic model should be refreshed, whatever this semantic model is. So this is very basic example of creating a pipeline. So again, 2 things that I want you to remember about regarding the pipeline. It's a data orchestration tool. Okay, that's the main purpose of using pipeline, to orchestrate the workflow, the workflow of different activities to complete a certain task. Okay, and I want you to remember that data flow can be run either as a part of this orchestration process, or this can be also executed outside of pipeline as a standalone Fabric item. So this is how you create a pipeline. And one last topic that I'm going to cover is how to implement the medallion design pattern in Microsoft Fabric. And first, I intentionally not calling it medallion architecture because I don't consider it architecture. But again, that's another story we can discuss offline. So I consider medallion as a design pattern. And this is, we have to admit that this is the most common data modeling pattern nowadays for the Lakehouse, not only in Fabric, but also outside of Fabric. And if you're wondering why this name medallion, this was coined by Databricks a few years ago, and now everyone adopted this naming. So essentially the idea is that the data within the Lakehouse will be organized in 3 different layers: bronze, silver, and gold. That's why it's called medallion. Now you may also hear terms such as raw, validated, or enriched, which I personally prefer, or raw, validated, curated. But essentially the idea is the same, to have different layers of the data in Lakehouse that are of different quality and serve different purposes. So let's quickly examine all of these 3 layers. Let's start with the bronze. Bronze layer is where we land the data from external sources in its original, in its raw state. Data is ingested as is without any additional transformations or changes, containing only metadata in addition. The purpose of the bronze layer is to serve as a repository of the historical archive of source data and enable quick data reprocessing when necessary, without the need to again connect to a bunch of different external sources outside Fabric. It's important to keep in mind that bronze layer contains unvalidated data, and in regards to storage format, the bronze layer usually stores the data in its original format. Then silver layer. In silver layer, data from the bronze layer is conformed and cleaned so that all the key business entities, all the concepts, all the transactions are available in a form of, let's say, enterprise view for ad hoc analysis, machine learning workloads, and so on. The data is enriched and validated. That means it can be trusted downstream for further analytic workloads. From a data modeling perspective, the silver layer, again, this is not set in stone, and you will see many variations on this, but usually the silver layer contains more third normal form-like tables. And in the silver layer, data is preferably stored in delta parquet format when we talk about Fabric, because then all the engines can take advantage of having this unified format already in place, and they can read the data from there. Finally, gold layer represents this, I like to call it icing on the cake, where data is, sorry, I need to take some water. So in gold layer, data is structured and organized to support specific project requirements. Because we are talking about a final stage in the data, data processing operation, data is additionally refined and cleaned. And in gold layer, you would also apply various complex business rules, complex business logic, use case specific calculations, and so on. From the data modeling perspective, again, not always, but usually gold layer is implemented through a Kimball style star schema, where the data is denormalized to support business reporting requirements. In terms of storage, data should be stored in delta parquet format. Again, the logic is the same as with silver layer, basically that all the engines in Fabric can leverage this format and read the data from there. To conclude, if you are planning to implement a data lakehouse architecture in Fabric, you should leverage the medallion data design pattern to logically organize the data and enable incremental and continuous improvement of the data quality inside the lakehouse. Okay, so yes, I think that was it from my side. Let me go through the chat and see if there are any questions. Question from Arno. So for data inside Snowflake, you would use mirroring, which is probably caching it locally in OneLake, whereas shortcut is like a symlink. Or does mirroring also work like a symlink, but through a different mechanism like JDBC or some other DB interface, like an external table? So mirroring works in that way. To be honest, I don't know what is symlink, but if I explain mirroring, maybe you will get to conclusion. So mirroring works based on the change data capture mechanism that exists in the source data. So I don't know how it's called in Snowflake. There is a change data capture mechanism. So what the mirroring will do, it will create a replica of this data, physical replica of this data in Fabric. So essentially with shortcut, it's slightly different because you don't have physical data in the lakehouse. With mirroring, you have physical data, which is in the form of a special item called mirrored database. And then based on this change data capture mechanism that exists in Snowflake, Fabric will check every X minutes or seconds. I think it's around 1 to 2 minutes latency if there were any changes in the data source, and it will automatically adjust the data within the mirrored database. That's how mirroring works. I'm not sure what symlink is to be honest.
Oh, sorry. That's
okay. I saw the Kevin answered already. Sorry, I was.
No, it's fine.
Thanks, Kevin. Yeah.
Symlink is just an abbreviation for symbolic link. So like you can do in Linux, etc., just a symbolic link to somewhere, and that's what Arno was getting at.
Okay. Yeah, sorry about that. And thanks for the answer. Is there a way to bring data changes from Postgres on Azure through pipelines? Do we have a direct connector which recognizes CDC changes, or do we have to rely on mirroring? So as far as I know, not yet. There is no direct connector for CDC changes. You can definitely bring the data, but you need to set the pipeline to run on a specific schedule. There is, as far as I know, there is no CDC mechanism currently that supports bringing data from Postgres to Fabric. And there is no mirroring for Postgres currently. So you need to rely not even on mirroring, you need to rely on establishing like a regular data ingestion process through pipeline or something like that. Okay, question from Nigel. What tool would you use to load daily CSVs into the data lake files area? Well, it depends how big they are. Yeah, if you load them just once per day, I would probably go with a pipeline. But also depends on what you plan to do afterwards. Yeah, if they are not big and you prefer to do some transformations during the data ingestion process, then data flows. So it depends on some things, some things to consider before I could give you a definitive answer. Yeah, copy data activity. I saw that someone responded. That's one of the options if you prefer just to bring them as is. If it's files area, if it's once per day, and yeah, if it's a small file, yeah, then it's easiest with the copy data activity. Okay, recordings. One challenge I have faced with medallion architecture is that it takes quite some time for the data to go through all cleaning and transforming stage. It's difficult if client needs data updated like every 20-30 minutes. Any inputs on this? I mean, this is not easy to answer. I don't know how you built your medallion architecture and how much data you have. Maybe you can try with some incremental loads. I don't know if this would help, but this is very broad questions. Sorry for not being helpful here. Is the mirror data like an exact replica but with efficient data transfer based on CDC, or do you also see the CDC in the output? That's a good question as far as I know, but yeah, maybe Kevin, you can also jump in, and Andy, if you know.
I was typing to the other. Which question are you on now? Because I was replying to the other one you just answered.
The last one, the mirror data like an exact replica, or is the CDC also visible in the output?
Oh, so it's kind of split. So you get the mirrored data come over, Arno, and then you can view all the CCD updates, etc. as well individually. There's actually a monitoring in place for the replication mechanism, basically.
Yeah.
So all of the data effectively ends up in OneLake. So in theory, say for example, Arno, if you were looking to migrate from Snowflake to Fabric, you could put the replication in place, monitor the replication, and once you're happy, stop the replication, and the data you've got in your Snowflake database will be in Fabric. There you go.
Yeah, thanks. What's the difference between bringing data through pipelines versus real-time intelligence experience in Fabric? Do we have an Azure Postgres CDC connector? Yeah, I mean, you would use real-time intelligence for streaming data. For pipelines are more for, let's say, batch data, more traditional scenarios for bringing data for data ingestion. Whereas real-time, you can use also to bring regular structured data inside, but it's more for streaming data scenarios. Do we have an Azure Postgres CDC connector? Where do we have? But where do we have this connector? Currently, currently Azure Postgres is not supported for mirroring and shortcuts for sure. So I'm not, if you can just clarify where do you mean about CDC connector? Yeah, if the gold layer has the star schema, can Power BI directly use that instead of creating a semantic model on the Power BI side? What is the best practice? I mean, you still need to create a Power BI semantic model. That's an item that is a blueprint for Power BI reports. So you still need to create a semantic model. But if you have a star schema in a lakehouse, then this semantic model simply is a copy of this structure that you have in lakehouse, and it will perform probably better when you have star schema in place. But yeah, it helps. I don't believe the CDC specific goals. This is answer from Andy, are exposed in the Fabric Mirror database. I don't know, honestly. I don't know the answer to this question. Yeah, real-time intelligence, you can test. Yes, there is also a feature called open mirroring. It's a little bit more complicated to implement and to explain than this one that works out of the box mirroring that we talked in this session. But there is a concept of open mirroring. Maybe we can share the link in the chat, which essentially allows you to connect to any data source or most of the data sources out there and mirror this data in Fabric. Now, I don't know if it's worth using open mirroring versus simply establishing a pipeline and connecting to Azure Postgres. So I'm not sure. After the launch of new SQL database in Fabric, which replicates data to OneLake in real time, in which scenario would I use the data warehouse now? This is a tough question. Data warehouse versus SQL database. The main difference is that with SQL database in Fabric, it's more oriented to like traditional transactional processing operations, writing data, intensive data writing, and it doesn't store data in Parquet. Whereas data warehouse is mainly still for analytical workloads, for larger amounts of data, for running analytical queries. You get, let's say, more powerful engine in the background when querying the data in the warehouse. But if you have like small data and you have extensive data writing operations as a requirement, then SQL database makes more sense. But that's a really high level answer. So it depends also on other things.
That's exactly. Right. I've just shortened it in the chat for you.
Yes, exactly. Any other questions? Okay, then if there are no more questions, I'll hand over back to my friend Kevin. And I would like to thank everyone for attending the session and for asking great questions, of course. Enjoy the rest of Data Weekender. You are on mute, you're on mute, Kev.
It's only the third time I've done this today. It's a common thing I've been doing all day long. So thanks to the session, it's obviously generated a lot of questions and a lot more queries. I suspect you'll have a few people reaching out to you on social media after this as well with some follow-up questions, etc. Do you want to just copy your credentials again in the chat so people know where they can reach you on their social media platform of choice? Be that Blue Sky, LinkedIn. Are you a Mastodon?
I used to be, but I'm inactive there for a while.
Yeah. So obviously just share your details again in the chat because you got quite a few follow-up questions from people as well. And I'm sure some of them will want to reach out to you for additional queries relating to this.
Absolutely, feel free.
And they want to keep an eye out when your book's available, etc. So, yeah.
Thanks, Kevin. Thanks for being a wonderful host.